So today we are going to talk about direct variation. Now this is going to look very close to our slope-intercept form, which was like this. Okay, so our direct variation has to follow two rules. It needs to look like this, or k equals y divided by x. Okay, and then the rule number two, it has to have a constant k, so it has to have that. So in this case, it looks very similar if you look here. Okay, but what it doesn't have is a b. Okay, so how could you get a slope-intercept form equation and not have a b? Do you guys remember? Do you remember enough about slope-intercept so far? We've got our slope, and then this is our y-intercept. So if this is not here, what number is b? Any ideas? 0. That is right. So if I had this equation, that b wouldn't be there anyways. So basically, this is the same equation. It just means that every single graph that we're going to have goes through the origin. Okay, it starts at 0. So what this means is when you have an equation, it has to look like this. So your question is, can you get the y alone? And if so, does it look like y equals kx? So the first question, how would you get the y by itself? Well, y is being multiplied by a 2. So you ask yourself, how do you undo multiplication? You divide. So we're going to divide by a 2. So this equation now looks like y equals, now here the deal is, if there's nothing with the x, there's an understood 1 there. So really this reads 1/2 x. Okay, so now if I'm asking you, what is the constant? What number is in the spot that the constant is in? Where the k is? It's 1/2. So your constant is 1/2. Okay, with b, can you get the y alone? So how would you move that 1 to the other side? It's being added. How do you undo addition? Subtract. So you're going to subtract 1 from each side. Y equals 2x minus 1. Now this is a perfect slope-intercept form equation, but does this look like y equals kx? No, because it has this added minus 1. So this is not a direct variation. And I'm just going to call it dv. And the reason it is not one, because of the minus 1. Okay, letter C. How could you get the y by itself? What's happening to y and how would you move it? 8's being added, so the opposite of addition is subtraction. So you're going to minus 8 from both sides. We get y equals x minus 8. Does this look like it's in this form, the y equals kx form? No, because it has this minus 8. So this is not a direct variation equation. Okay, the last one here. How could you get y by itself? Well, y is being multiplied by a 3, so how do you undo multiplication? Divide. So we're going to divide by a 3. So I get y equals, we can just write this as a fraction, 2/3 times x. What is your k? Yeah, 2/3. So this direct variation, it sounds kind of difficult or kind of scary, but all that it means is that you can write it in that form. It's not going to be like slope-intercept where there is specific y-intercept, because with a direct variation, the graph always has to go through the origin. Okay, so now we are going to try to identify if it's direct variation from the table. So the rule number 2 is that it has to have a constant k. Now, if you take the direct variation equation and you were trying to solve for k, how would you split up that x and that k? You would divide by the x. We're kind of flipping it to the other side of the equation, but so we have y divided by x equals k. Okay, now this is helpful because in order to be a direct variation situation, you have to have a constant. So you are just going to take your y divided by your x. So these are all in like xy. So for example, 3 divided by 1 is 3. 6 divided by 2 is 3. And then 9 divided by 3 is 3. Did we have a constant? Yes. Constant equals 3. So in this situation, there was a direct relationship between the pounds and the price. 1 pound was $3, 2 pounds was $6, 3 pounds were $9. So this is a direct variation equation because they're directly related. There's no other factors involved. Okay, so let's do the next one. This is our x, this is our y. So if you took 3, or I should do 3 divided by 10, then we're going to have 1.5 divided by 20, and then we have 1 divided by 30. I know this one's a little bit trickier. So we have 3 divided by 10, we get 0.3. 1.5 divided by 20, we get 0.075. And we get 1 divided by 30 is 0.03 repeating. Are these the same? No. So you would say no, not a direct variation because there is no constant. Okay, the graphs are probably the easiest. So I'm going to give you 2 direct variation examples and 2 not direct variation. Okay, so the rule with direct variation is that it has to go through the middle, the origin. Okay, it can be going up, it could have a positive, or it could have a negative slope, as long as it went through the origin. So you might want to write that on there, has to go through the origin. Okay. And then not a direct variation would just be any graph that didn't go through the origin. Okay. Now, I want you to think about why is this the case? Because I've given you like just the kind of the little rules here by looking at them, by looking at equations, tables, and graphs. But now I really want you to understand why. So when I say directly related, it means what happens to X has the same exact effect on Y every single time. There's no other number involved. And that's why we don't have a Y-intercept, or what you might want to call it. And so, for example, this one right here, it says an eastern box turtle travels on the ground at a speed of about 18 feet per minute. Give an equation to represent the situation and determine if it's a direct variation situation. So for example, if I were going to write an equation for this, I would say that like my y, the total distance, is going to equal 18 feet per minute, that's his speed, times how many minutes he travels. Okay, so I have total distance, it's my y, and I have number of minutes that he traveled. Does this look like a direct variation expression? Yes. Now I'm going to also talk about this in the form of the k, even though we know what k equals. K is always going to be y divided by x. So if you took his total distance and you divided it by the number of minutes, you would get his constant speed. Okay, so this makes sense, where if you put the 18 in there, 18 equals the distance divided by the number of minutes, and it's going to be that same every single time because we know that turtle was moving at the constant speed. So other situations that you might think about is, okay, Jenny works and she gets paid $8 an hour. That would be a constant rate that she gets paid, and there's nothing else involved. So that would be like y equals $8 per hour. Okay. We could say that every day that they work on the highway, they get 2.5 miles completed. Okay, there's a constant there. And so you can come up with direct variation equations anytime that one factor has a direct effect on the other factor.